And hello 8P Physics students, welcome to another problem with Mr. Kirsten here. Today we're going to be talking about waves. Hi! Chapter 11, problem 37 we're going to be talking about. Alright, there are two types of waves out there. We have transverse waves and longitudinal waves. A transverse wave is like a water wave, okay? It's kind of what I think of when I think of waves. That is, you have kind of what we call a couple parts to it. We have, the top of a wave we call the crest. The bottom of the wave we call a trough. And this distance from the top of the wave to the equilibrium position, or the flat water line, if you will, is called one amplitude. Okay, and of course the distance from the peak of one wave to the peak of the next wave, this distance here, right, from here to here, that is called one wavelength. And in physics we use the Greek letter lambda to represent wavelength. Okay, now longitudinal waves are where the motion is in line with the direction of propagation. Transverse waves are called transverse because the motion of the individual particles is perpendicular to the direction of propagation of the wave, the direction the wave's moving. Now I'm going to have a hard time drawing a longitudinal wave for you, but longitudinal waves deal with compressions and refractions, okay? So in air, it's kind of like the air's being squished together or the air's being pulled apart. You could also do this with a spring. Sound is a good example of a longitudinal wave. When you beat on a bass drum, the drum vibrates back and forth and it either compresses the air or expands the air, making a compression or a refraction. But longitudinal waves have wavelengths just like transverse waves do. All right, the wavelength would be the distance between compressions. So that's a little background on waves there, but let's get to our problem and do some problem solving here. So problem 37 says a sound wave, right? So there's a person, right, doing their physics and they yell out, "Help, I need help with my physics," right? And the sound propagates out, right? Okay, this person makes a sound and the frequency of this sound is 662 hertz, or 662 compressions per second, right? Hertz is a cycle per second. By the way, the range of human hearing, you won't have to know this for any tests or anything, is 20 to 20,000 hertz. As we get older, that range gets smaller. But Mr. Kirsten's nice and young, so of course he can still hear the whole range, right, everyone? Okay, so this sound wave has a frequency of 262 hertz. The speed of sound, it says, in this air is 343 meters per second. That's about 660 miles an hour, otherwise known as Mach 1. Anyway, the question says, how far apart are the waves' crests or compressions? And for this, we are going to use the wave equation. What in the world is the wave equation? That's this one. That's a biggie, okay? This says the speed of propagation of a wave in meters per second is equal to the frequency of the wave, so how many waves per second you have, and that's given in inverse seconds or hertz, times the wavelength of the wave. I always think of this like running. If you're a cross-country runner and you take 3 steps per second and each step is 1 meter long, you're going to be running at 3 meters per second. All right? Okay, so we're going to use this equation to help us solve for the wavelength of this wave, of this sound wave. All right, so let's do a little algebra here. We are going to get that the wavelength is equal to the speed of the wave divided by the frequency, which is going to be 343 divided by 262. And let's bring that up here. And we would get then that the wavelength of this sound wave is 1.31 meters if you type that into your calculator. Okay? So we use the wave equation to solve for the frequency of this wave. Nice work. Okay, I got something a little different today. Instead of a joke, we're going to do something just as entertaining, all right? You guys ready to see something just as entertaining as a physics joke? We're going to do extreme close-ups of Mr. Kirsten's dog, all right? Here we go. Oh my gosh, what are we doing? Raven, come here. Oh, come here, Raven. Oh my gosh, say hello to the physics students, Raven. Say hello. Oh my gosh, Raven. Oh my gosh, you're being attacked. Oh, hello. Oh, nice work. Oh, say hello. Raven, look this way. Say, I want all the physics students to do their homework. All the physics students, oh, do your homework. Do your homework, and my tail will do this. It will wag. Oh, all right. Oh, Raven, do your homework. Oh, okay. All right, nice work.